In this problem, we want to find the given value. So we've got f of x is equal to the square root of 3x plus 16. And then we want to evaluate after we find the second derivative. Okay. Well, first off, we're going to rewrite this as 3x plus 16 to the 1/2 power. We never want radicals. We always want to rewrite it. And the square root is always the 1/2 power. Now for our first derivative, this is the chain rule, specifically the general power rule. We got parentheses to a power. So take our power, put it out in front. So we got 1/2. What's inside your parentheses remains the same. Lower your power by 1. So it'll be 1/2 minus 1 times the derivative of what's inside your parentheses. So again, take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. So then 1/2 minus 1 gives us negative 1/2. The derivative of 3x plus 16 gives us 3. And I'll take that 3 and put it out in front, and 3 times 1/2 gives us 3/2. Let's try it again. And then we got 3x plus 16 to the negative 1/2. Oops. Let's try it again. My writing's horrible. There we go. Now we're ready to find our second derivative. And numbers out in front just stays out in front. This is the chain rule again, general power rule. We got parentheses to a power. So we're going to take our power, put it out in front. What's inside your parentheses remains as is. You don't change it. Lower your power by 1. So that becomes negative 1/2 minus 1. And then again, times the derivative of what's inside the parentheses. Keep in mind what we're trying to find, because I'm getting ready to scroll. We're trying to evaluate that. So after we find the second derivative, we want to plug 3 in for x. Okay, 3 times negative 1 is negative 3. 2 times 2 is 4. 3x plus 16. Negative 1/2 minus 1 is negative 3/2. The derivative of 3x plus 16 is 3. So then 3 goes out in front, so that gives us negative 9/4. 3x plus 16 to the negative 3/2. We don't want any negative exponents, so the part with the negative exponent I'm going to take to the denominator. So it's going to become negative 9 over 4 times 3x plus 16 to the positive 3/2 power. Remember, you take anything opposite in a fraction, the sign of the exponent changes. So the negative 3/2 becomes a positive 3/2. And that's our second derivative. Well, we now want to plug in 3 for the x. So everything remains the same. I'm going to make these brackets just so I can separate them. And where our x was, we put in parentheses. And again, evaluating a function is whatever number's inside your parentheses here is automatically what you put in right here. So we put a 3 in there. So that gives us negative 9 over 4. 3 times 3 is 9 plus 16 to the 3/2 power, which gives us 4 times 25 to the 3/2 power. Now we had a property back in intermediate algebra, algebra 2, said if you have a number to a fractional power, you can split it up in this manner. You can rewrite it as 25 to the 1/2 power raised to the 3rd power. Your number on top, the numerator, the 3, you put it on the outside of the set of parentheses like this. The reason why you do that is what's inside the parentheses now I can rewrite in radical form. 25 to the 1/2 is the square root of 25. which then gives us negative 9 over 4, and square root of 25 is 5, so we've got 5 to the third. 5 times 5 is 25, times another 5 is 125. And I think that gives us 500. Let me think. Yeah, 500. So assuming no basic math error, that would be your answer. Negative 9 over 500.